that you call the resources. Otherwise, it will not work if you will go searching for resources.
Okay, now I have started the recording. So this is the examples is given. That is V of t is the input which is connected to the given network, that is R1, L, R2, C, and the output is taken across R2 and C. We have to find out the transfer function V0 of S divided by Vi of S of a given electrical network. So to find out the transfer function, first we have to apply the KVL to the input loop. Input loop means in which the input is connected. So the input is connected to the R1, L, R2 and C. So we will apply the KVL to the input loop. So KVL to the input loop becomes Vi of t, it is equals to R1 into I of t plus L into dit by dt plus R2 into I of t plus 1 by C integration of I of t into dt. Now this is the input loop equation. Now we will take the Laplace transform of the above equation. So Laplace transform becomes Vi of s, it is equals to R1 is constant and I of t becomes I of s plus L into d by dt becomes s. So L into s plus I of t becomes I of s plus R2 into I of s plus 1 by c constant, so as it is, and integration becomes 1 by s. So this becomes 1 divided by C into S multiplied by I of t becomes I of S. Now we will take the I of S common. So we have the equation Vi of S, it is equals to R1 plus S into L plus R2 plus 1 over S into C multiplied by I of S. So this we can write down Vi of S. So we can write down Vi of S, it is equals to, we will take SC constant. So it is common. So this becomes S into R1 into C plus S square LC plus S into R2 into C plus 1 bracket complete multiplied by I of S. Multiplied by I of S. We have taken S into C is common. So multiply S into C to all the terms. So this becomes S into R1C plus S square LC plus S into R2 into C plus 1 divided by this one. So this we can write down Vi of S, it is equals to, we will take uh, S square LC, that is the highest power. So here we have S square LC first plus S into R1C plus S into R2C. In this one we will take SC common and in bracket it is R1 plus R2 plus 1 as it is, plus 1 as it is, divided by S into C bracket complete multiplied by I of S. So this is our equation number A. Sorry, equation number A. Now apply KVL to the output loop, to the output loop. Now see here in the output loop, what is the output is taken across R2 and C. See the figure. See the figure. In the figure, in the figure, the output is taken across R2 and C, and the currents flowing through R2 and C is I of t, that we have assumed. So we will apply the KVLs to this one. So we have V0 of t, V0 of t, it is equals to R2 into I of t plus 1 by C integration of I of t into dt. That is the voltage across R2 and C. That is voltage across R2 and C. Now take Laplace transform of above equation. Now take Laplace transform of above equation. So this becomes V0 of S, it is equals to R2 as it is, and I of t becomes I of S plus 1 by C as it is, and integrations becomes 1 by S multiplied by I of S. So this is our equation. So we will take I of S common. So V0 of S, it is equals to R2 plus 1 by S into C multiplied by I of S. So this we can write down V0 of S, it is equals to, we will take SC common, so this becomes S R2 into C plus 1 multiplied by I of S. So this is our equation B. So this is our equation B. Take ratio equation B to equation A. That means divide the equation B to the equation A. So this becomes V0 of S divided by Vi of S. What is the equation A? Equation A, see in the left side, it is Vi of S. So we will V0 of S divided by Vi of S, it is equals to. It is equals to. What is to the right side of the V0 of S? That is S R2C plus 1 divided by S into C divided by, what is to the right side of the equation A? That is S square LC plus S into C R1 plus R2 plus 1 divided by SC. So we will write down here S square LC plus S into C R1 plus R2 plus 1 divided by S into C. Here it is multiplied by I of S, and this is also multiplied by I of S. Now this I of S and this I of S gets cancelled. This SC and this SC gets cancelled. So V0 of S divided by Vi of S becomes S into R2C plus 1 divided by S square LC plus S into C multiplied by R1 plus R2 plus 1. So this is our transfer function. So this is our transfer function. This is the answer. This is answer. This is the transfer function of a given network. This is transfer function of given network. Understood, students? This one. Hello. Hello.
Yes, sir.
Yes, sir.
Okay. Yes. Now we will see one more example.
Steps are creating tasks and organizing the workflows. अभी इसमें क्या काम करना है? Responsible और authorize कर दो लोगों को.
This is module 2.
For those particular tasks. Make people.
Now we will see one more example. One more example.
Creating tasks and organizing workflows.
This is R1.
Authenticate करके चलेगा नहीं. You as a project manager.
This is L.
Project team leader.
This is R2.
और ये project member. आप किसी भी रोल में अपने आप को रखें जो working for project. So हमारा project team member hierarchy सबसे नीचे. तो ये आपको task देके चलेगा.
This is Vi of T. This is C. This is C. And here we have V0 of T. V0 of T. Now find transfer function V0 of S divided by Vi of S of a given network, of a given electrical network, which is shown in the figure, which is shown in the figure. So now see here, in this one, we will assume this is current I1 of t, and this current is I2 of t. This is, I assume, it is flowing in a clockwise direction. In the first loop, that is in the input loop, the current is I1 of t, and in the output loop, the current is I2 of t. The current is I2 of t. Okay. Now here in the solution, again apply KVL to the input loop. Apply KVL to the input loop. So in the input loop, there is R1, L, and Vi of t. This is the loop 1. Let us say this is loop 1 and this is the loop 2. This is the loop 2. So apply the KVL to the loop 1. Loop 1 is your input loop and loop 2, that is the output loop. So Vi of t, so Vi of t, it is equals to R1 into I1 of t plus L into di1 of t divided by dt. So this is our first loop. Sorry. One minute. This is in the inductance. There are the two currents are flowing. One is I1 of t and another is I2 of t. I1 of t is flowing in the downward directions and I2 of t is flowing in the upward direction. We are applying the KVLs to the input loop, and input loop current is I1 of t. So we can have d by dt. We can have d by dt in bracket I1 of t minus I2 of t, minus I2 of t, because I1 of t is flowing in downward directions and I2 of t is flowing in the upward direction. Both the currents are flowing in the opposite directions. That's why we have a difference of the currents is there, that is I1 of t minus I2 of t, and derivative of it is, that is d by dt. That is d by dt. Now take Laplace transform of above equation. Laplace transform of above equation. So this becomes Vi of S, it is equals to R1, and I1 of t becomes I1 of S plus L as it is, and d by dt is S in bracket. I1 of t becomes I1 of S minus I2 of S, this equation that we have. Now after expanding these ones, we have Vi of S, it is equals to R1 I1 of S plus S into L I1 of S minus S into L I2 of S. If we simplify this one, then we have Vi of S, it is equals to R1 plus S into L bracket complete multiplied by I1 of S minus S into L I2 of S minus I2 of S. So this is our equation A, let us say. So let us say this is our equation A. Now, apply KVL to the loop, KVL to the output loop.
So you are responsible in the execution state that the budget should be managed.
Now apply the KVLs to the output loop. Output loop which is consist of resistance R2, capacitance C and the inductance L. And L is the common to the input loop as well as to the output loop. Now we are applying the KVLs to the output loop. That means we are applying the KVLs to the loop number 2. The current of the loop number 2 is I of t. So this becomes I2 minus I1. The current flowing through the inductance becomes I2 of t minus I1 of t minus I1 of t. So after applying the KVLs, we have the equation R2 I2 of t plus current flowing through the R2 is I2 of t. Current flowing through the capacitors is again I2 of t. So this becomes plus 1 by C integration of I2 of t into dt plus currents flowing through the inductance is I2 minus I1. I2 minus I1. So it is L d by dt in bracket I2 of t minus I1 of t. I1 of t, it is equals to 0. It is equals to 0 because no EMF is connected in the loop number 2 or in the output loop. So we can have the algebraic sum becomes 0. Now take Laplace transform of above equation. Take Laplace transform of above equation. We have R2 constant and this becomes I2 of S plus 1 by C, that is constant. Integrations becomes 1 by S multiplied by I2 of S plus L as it is. D by dt is S and this becomes I2 of S minus I1 of S. It is equals to 0. It is equals to 0. So we will expand this one. So this becomes R2 of S, R2 into I2, R2 into I2 of S plus 1 by S into C, I2 of S plus S into L, I2 of S minus S into L, I1 of S, it is equals to 0. So we will collect the similar term. So this becomes R2 plus S into L plus 1 by S into C, I2 of S, it is equals to minus S into L, I1 of S. Okay, sorry. This is minus, it is equals to 0. It is equals to 0. Now this we can write down S into R2 into C plus S square LC plus 1 divided by S into C. This becomes I2 of S, it is equals to S into L, I1 of S. I1 of S. This we get. So we can write down I1 of S, it is equals to I1 of S, it is equals to S square LC plus S into R2 into C plus 1 divided by this becomes S into L comes here. So this becomes S square LC. S square LC is complete multiplied by I2 of S. This is our equation B. B है ये है. Okay. Now this is our equation A. This is our equation A.
Answer announces the completion. Answer cannot announce the completion because if it announces the completion.
Okay. Now see here in the equation A, there are the two terms I1 of S and I2 of S. And here in the equation B, we got I1 of S in terms of I2 of S. Now substitute or put equation B in equation A. Put equation B in equation A. Now we will substitute the value of I1 of S in the equation A. In the equation A. So this becomes Vi of S. It is equals to, what is that? This is R1 plus S into L. Okay. In bracket R1 plus S into L. Okay. Multiplied by I1 of S. What is I1 of S? I1 of S, it is equals to S square LC plus this one multiplied by S square LC plus SRC plus 1 divided by S square LC, okay, multiplied by I2 of S and then minus SL I2 of S minus SL I2 of S. These equations that we have. These equations we have. Now we can have Vi of S, it is equals to in bracket R1 plus S into L in bracket S square LC plus SRC plus 1 divided by S square LC. This I2 and this I2 gets common multiplied by S into L, and this complete bracket multiplied by I2 of S. I2 of S. So this we can write down Vi of S, it is equals to R1 plus S into L as it is. Then we will put here S square LC plus SRC plus 1 minus this S square LC we will multiply to the S into L. So this becomes S cube L square into C divided by, this is common now. So this becomes S square LC multiplied by I2 of S multiplied by I2 of S. So this is our equation number C. This is our equation number C. We will highlight this one. This is the important equation. This is equation number C. Now, from output loop, we get from output loop. That means from the loop number 2, the output is taken across the capacitor. What is the current flowing through the capacitor? That is I of t. So the voltage across the capacitors, that is nothing but V0 of t. V0 of t, we can have V0 of t, it is equals to the voltage across the capacitor. So this becomes 1 by C integration of I2 of t into dt. Into dt. So take Laplace transform of above equation. Laplace transform of above equation. So we have V0 of S, it is equals to 1 by C into S into I2 of S. This is our equation D.
And it will be helpful for you if you prepare the
This is
slide
our equation D.
evaluation of team's performance. Very, very important.
Now see here, in the equation C, there is a I2 of S, and in the equation D, there is also I2 of S. That's why we have converted the current I1 in terms of I2. I1 in terms of I2 from the equation B. See here, from the equation in this one, we have applied the KVLs to the output loop. And from the output loop we got the currents of I1 of S, I1 of S in terms of I2 of S, and that we have substituted in the equation A, and then we get the equation Vi of S, and that we called it is the equation number C. And from that one, again from the output loop, that we have calculated V0 of S in terms of I2, and Vi of S, that also we have calculated in terms of I2. Now take 1 minute. Take ratio of equation D to A. Sorry, D to C. D to C. D to C. So V0 of S divided by Vi of S, it is equal to what is D equation in the right side? It becomes 1 by S into C multiplied by I2 of S divided by what is there in the first equation, that is R1 plus S into L, R1 plus S into L multiplied by S square LC, S square LC plus S into RC, S square LC plus S into RC plus 1 minus S cube L square into C divided by what is there S square LC, S square LC. This complete is gets multiplied by I2 of S. Now this I2 of S, this I2 of S gets cancelled. This S square C gets cancelled with square and C. So here we have V0 of S divided by Vi of S. It is equals to 1 divided by R1 plus S into L multiplied by S square LC plus SRC plus 1 minus S cube L cube. This becomes square. This becomes square divided by S square, that becomes S now, and C gets cancelled. So here is the L, and this is our transfer function. This is your answer. Got this one? Hello? Yes, students?
Yes, sir.
Okay. So this is the solution for this type of equation which is given. R1, L, R2, C, it is given, and we have to find out the transfer functions of that particular equation. So this is about the transfer function of this one. Now see here, in a minute that we will see one more this one simple example.
variety of work.
This is the
Enhance your project quality. So this all this so negative and positive.
module 2. This is module 2. Now,
all this is done in the closing stage of the
in this one,
also provide all the required documents, project documents, submit those documents, and hand over those documents to the client. It will be helpful for the client to manage whatever production facility you have built.
let us assume
That all the manuals or documents, right, or the drawings,
the circuit is given, the mechanical.
right? That's the closing stage. You understood this? Closing stage.
Here it is. This is M2.
Stage gate process. So,
1 minute. I will draw once again.
Stage. Just a minute. Project phases and stage gate process as mentioned in the slides. So,
This is M2.
whenever the project is executed, it is selected, right? There is a stage gate process that is applied by the project organization.
This is M1.
Look at this flowchart.
This is F.
The first is
This is K2.
generation of an idea.
And here,
You're thinking of
this is
undertaking
K1.
one particular project. So you let's suppose 10 or 15 different ideas. Out of that, you select one particular.
Here,
But not
the
every idea
displacement is
goes
given.
on to make a project, and not every project is completed till the final stage. Remember this.
X of t.
Because, see, this is
Here,
with the help
it is
of
Y of
stage
t.
gate process. And stage
And
gate
to
process
this one,
helps us to halt or stop the project
here it is
to avoid
U of t.
unnecessary
Obtain.
Stage gate process will ensure us, help us to finalize, yes, this should be.
अच्छा ओके
One idea is to start working on it.
obtain
Initial documents. There are 2 or 3 teams working on it.
transfer function U of sorry
The first gate.
Y of s
Whether we should actually go ahead
divided by
stage
U
one.
of s of a
Must meet,
given
should meet criteria. So you decide and
mechanical
discuss
system.
on all the criteria and all the factors, and then you go on to the stage.
Obtain
In
transfer
stage
function
one, stage,
Y of s divided by U of s of a given mechanical system. We have to find out the transfer functions between this Y of s, Y of s and U of s. U of s is the input displacement and Y of s is the ultimate, the last displacement of the circuit final, or we can say that it is a final displacement Y of t divided by U of t. So Y of s divided by U of s, that becomes our transfer functions of a given electrical network that we have to find out. Now for that purpose we have to draw the free body diagram. Now see here, the time is not left today, so tomorrow that we will see the transfer functions, how that we can find out the transfer function of a given network. Okay, and we will find out we can draw the F to V analogy, electrical equivalent of this network also. Okay, so today we will stop here, and
as per situation. Then only you will go for state.
Today we will stop here.
Classification should be